Hi guys, today we will be going over lesson 2.2, the limit of a function. So let's start. What is a limit? Well, a limit is the value that a function approaches as the input approaches another value. So graphically, we can see that here, and in other words, to explain this graph, we can say that as f of x becomes closer and closer to a single number g from both the left and the right side while x approaches c, the limit of f of x as x approaches c is g. And we can see that here, as f of x, you can have c being approached from the left and the right side, and the value that you'll get, so your output will be g when x is c. Let's take a look at solving graphically. Here in this problem, it's asking us to find the limit as x approaches -3 of the function f of x. And it's saying, does the limit exist, and if not, why not? Well, when we graph out our function, we can see that in the black we have ln of -x plus 3, and in the red we have ln of parentheses -x plus 3. And we can see that at -3 they approach two different y values, so that's conflicting our definition of a limit. So therefore, no, the limit does not exist because the function approaches two different y values as x approaches -3. It'll approach around 4.1 from the left and 1.8 from the right. So this can be denoted as limit as x approaches -3 from the left, that little negative sign of f of x equals 4.1, and limit as x approaches -3 from the right, that little positive sign, f of x equals 1.8. Now let's take a look at infinite limits. Let's start off with this problem right here. The limit as x approaches 2 of y equals x squared minus 2x plus 4 over parentheses x minus 2 parentheses squared. So, well, let's take a look at the graph. And when you take a look at the graph here, you can see that there's a vertical asymptote at 2. Well, why is there a vertical asymptote at 2? Because here, if you plug in 2, then you're going to get 2 minus 2, and your function is going to be over 0 where it's undefined. So that's why you have a vertical asymptote. Well, however, if you see what it's approaching from the left side and the right side, you can see that they're both going up towards infinity. So therefore, you can come to the conclusion that the limit as x approaches 2 from the left equals infinity, and the limit as x approaches 2 from the right equals infinity. So therefore, the limit as x approaches 2 of this function is equal to infinity. Now, if we take a look at our second problem here, this one right here, the limit as x approaches -infinity of this function, then we're going to put in direct substitution, and you get -infinity over -infinity, which isn't equal to 1. It doesn't work. It's an undefined value. So then we're going to go over here, and we're going to actually divide by x on both the numerator and the denominator. And after that, we get this function, and we can use our direct substitution here, and that will give us this function 1 plus 0 over 3 plus 0, and that equals 1 over 3. And your answer is 1 over 3 as the limit approaches -infinity. Let's take a look at methods for solving limits. So in this example, the limit as x approaches 4 of this function, okay, well, one way we're going to solve this is we're going to actually factor out the numerator. And by doing this, you're going to see that you're going to get x minus 4 and x minus 4 on both the numerator and the denominator. What that allows us to do is it allows us to cancel these x minus 4's out, and we're going to be left with limit as x approaches 4 of 4x plus 2, and then we're going to use direct substitution to find our solution to be equal to 18. So therefore, our limit as x approaches 4 of this function is equal to 18, and that's how you would write it out. Well, let's take a look at our second problem here. Number 2. So this example is asking us to find the limit as x approaches 64 of 2 minus root x over 4 minus x. And so we're going to go through and solve and multiply by the conjugate on both the top and the bottom, and this will give us 4 minus x on the top, and that'll give us 4 minus x on the bottom. And like in this example on top, we're going to cancel those out, and we're going to get 1 over 2 plus root x. So then we can use our direct substitution and plug in the 64, and you're going to get 1 over 10 as your final answer. Now, if you look down here on the bottom left, you can see that there are a few more ways that we can solve. So we can graph the function out, we can simplify down to as simple a function it can be to see its basic components, and then cancel out numbers like we just did in these two examples. And then as a last resort, we can also plug in numbers to make a table and see where the limit will lead us. Let's go over some example problems. Number 1. The question is asking us to find the limit as x approaches pi from the right of x cotangent of x. When we try direct substitution, we get that the value is undefined. So we turn to our graph. On the graph, we can see our value of pi, and we want to solve from the right, so we can see that it's going towards infinity. So therefore, the limit as x approaches pi from the right of x cotangent of x is equal to positive infinity. However, let's say they asked us to find the limit as x approached pi. Well, then the answer would be does not exist, because the value approaching from the left is negative infinity, and therefore you have two conflicting infinities, and the answer is does not exist, because the limit will not exist. Let's take a look at the second one. Limit as x approaches infinity of that function. Well, direct substitution doesn't seem to work, so why don't we move in and we want to divide by x squared on both the numerator and the denominator. And when we do that, we get 7 plus 1x minus 100 over x squared over 2 minus 5 over x. And we can use our direct substitution, plug in our infinity, and we will get 7 over 2 as our final answer. Here are some common mistakes in how to avoid them. Number 1, using wrong notation or forgetting to add it. Remember, the small positive sign means x from the right side, and the small negative sign means x from the left side. Some advice is to always double check your work and make sure that the limit is being approached from each correct and respective side. Number 2, always write that the limit of x approaches h for every step when solving for limits, with h being the number that you're solving for. Some advice is to make sure to write out each limit sign for all steps until the very end when you finally use direct substitution and you can stop writing the limit sign. Number 3, thinking infinity minus infinity is going to equal 0, infinity over infinity is going to equal 1. Well, both are indeterminate forms, so make sure that you can see what else you can cancel or do to the problem because it is not done. Number 4, multiplying incorrectly or prematurely when solving conjugate type problems or really any type problems. Some advice is to wait to see what you can cancel or you will get stuck. Thanks for watching. I hope the video was helpful. See you next time.